In this video, I'd like to discuss how to solve linear inequalities. And what I mean by an inequality is essentially an equation, but instead of having an equal sign, you either have a greater than, a less than, a greater than or equal to, or a less than or equal to. And what we mean by linear is that for the variable, it's not raised to any sort of power other than 1. You can always think of it as being like an invisible 1 as the exponent when you don't see one. But if it was squared or cubed, or if we were taking a square root of it, or if we were multiplying x by some other variable, then it would no longer be linear. But since it's to the first power and it's not multiplied by another variable, then this is linear. And to solve this equation, or I should say this inequality, is essentially the exact same way you would solve an equation. The only difference is that if you multiply or divide by a negative number, you have to flip the sign. So what we can do to start this first problem is we want to essentially get x by itself, so we have to get rid of anything on that side of the inequality that's not x. So this plus 1 we need to get rid of, and we can cancel that out by subtracting 1 from each side, since plus 1 minus 1 cancel out and give us 0. And then we have 3x is less than 4. And from here, we want to get rid of this multiplication by 3, and we can cancel out multiplication with division, so that x is less than 4/3. And if you want to know what this is as a decimal, it is 1.33 repeating. And one thing you can do with these inequalities is you can graph them on a number line. And this will help give you just a better idea of what's going on. So first I'm going to write 0 as my reference point, and then we can have 1, 2, and so on. And this 4/3 would fall in right about here. And I'm going to use an open circle since x is less than 4/3, but we don't have it being equal to 4/3. If it was less than or equal, then we would fill in the circle to show that that particular point is included as well. But in this case, since it's not equal to, we'll leave it as an open circle. And we want all x values less than 4/3. So all values over here, and you can test this to make sure it's true by plugging in one of the values in your solution set. So 0, for instance, would be a solution to this equation. We can plug that in here. 3 times 0 is 0, plus 1 is 1, which is less than 5. So you can see that testing it did work, and you did find values that were part of the solution set. So this x being less than 4/3 is the final answer for question number 1. So now we can move on to question number 2. And in this case, we have to deal with that scenario that I mentioned where it's slightly different than an equation now. So basically, we want to get x by itself, and to do that, we have to get rid of this multiplication by -3. And to cancel out multiplication, we can divide each side by that -3. And something divided by itself is always 1. So -3 divided by -3 would just be 1 times x. And on the right-hand side, we would have 9 divided by -3, which is -3. And like I mentioned in the beginning, the only difference between an equation and an inequality is that when you multiply or divide by a negative number, then you have to flip this inequality sign. So instead of being less than or equal, now it's greater than or equal to -3. So this right here would be our solution, and we can get a picture of this on the number line. And then we have -1, -2, and -3, and then x is always bigger than or equal to -3. So in this case, we're actually going to fill in the circle because x can actually equal -3. And then it's all values bigger than this. And again, we can test this since 0 is part of the solution set. So if you plug in 0 here, you get -3 times 0, which is 0, and that is less than or equal to 9. So 0 is definitely a member of that solution set. And maybe in some later video, I'll discuss why this is true, why we need to flip the sign when multiplying or dividing by a negative number. But for now, it's important just to learn how to do it. So now moving on to question number 3. This is the most challenging question in the video. And we have this fraction here that we're going to want to get rid of. And we also have this set of parentheses. So we have two choices here. We can either get rid of the fraction first, or we can distribute first. And either way is completely valid. I am going to distribute first. So when I distribute this 2 to the minus 3x, I get minus 6x. And 2 times positive 4 is plus 8. This is bigger than 2x over 3. And now that the parentheses are gone, I can focus on getting rid of this 3. Now, to cancel out this division by 3, we want to multiply both sides of the equation by 3. So we can do that. And just keep in mind that if you're going to multiply each side of the equation by some number, that you have to multiply every term on either side of the equation or inequality by whatever that number is. So the first step I'm going to do is distribute this 3 to both of the terms on the left-hand side. So 3 times minus 6, I get minus 18x, and 3 times plus 8 would be plus 24. And on the right-hand side, I have this 3 divided by 3, which we know is 1. And 1 times 2x is just 2x. So the 3's essentially cancel each other out. And from here, I have to get all of the x's on one side of the equation. And if I want to avoid dealing with that other rule where if you multiply or divide by a negative number, you have to flip the sign, then what I would recommend is moving all of your x's to the side with more x's. So that would be this side, since there's actually a positive amount of x's here. And to move the minus 18x over there, I would just add 18x to each side of the equation, or I should say the inequality. And then we have 24 is bigger than 20x. And to finish off this problem, what we can do next is divide each side by 20. Since 20 divided by 20 is just 1, so we have 1x here, or just x. And 24 divided by 20, each of these numbers is divisible by 4. So we can divide them each by 4, and you get 6 over 5 is bigger than x. So let's look at this on the number line. So we have 0, we'll say 1 and 2, and 6/5 is 1.2. So that would be right about here, and x is smaller than this, but it's not equal to 6/5, so it's going to be an open circle, and then all x values smaller. And we can again test this. It's a little bit more difficult because of the fractions, but let's just test with 0, since that's always an easier value to test. So if we plug 0 back into this original equation, this term would just become 0, and then we'd have 4, and then you'd have 4 times 2, which is 8. So you end up with 8 here. It's bigger than 2 times 0 divided by 3, which is 0. So this is true, which means that 0 is indeed a part of our solution set. So we can feel more confident that 6/5 is bigger than x.